Start now.
Okay, good afternoon, respected sir present here, and good afternoon, my friends. And myself, Rajat Subramanian, and Department of Mechanical Engineering, Maulana Abdul Kalam Azad University of Technology. Here I am going to present my conference paper on the topic analysis of ground source heat pump. So, first of all, know the definition. What is the geothermal energy? That means in dictionary that is relating to the internal heat of the earth. The earth act as a giant solar collector, absorbing approximately uh, radiation, 50% of the radiation emitted by sun on this earth. And air temperature may fluctuate as much as 50 degree Fahrenheit above and below the annual average. However, the only few feet below the surface, the changes in earth temperature are much less severe. So by this graph is from Maslak, Istanbul, Turkey. You can see that throughout the year, the temperature is changing and this ground upper surface. But if you go for the some 6 to 7 meter depth in the ground, the temperature are fixed near about 15 to 17 degrees throughout the year. There is nothing change in this on outside. So we can utilize this natural things for. So global heat pump market is a huge opportunity for global. The development is for near last 60 to 7 years developing this ground heat pump market. And currently in 2019, the market is nearly $48 billion market dollar. And it is projected in 2025 that is the market can be $102.5 billion and number of unit installed and near about 16 million units. So now what is heat pumps? Why this is the heat pumps required? So heat pumps move energy from one location to another location. Normal in natural condition, heat is moving from higher temperature to lower temperature. If you are looking for the energy moving from lower temperature to higher temperature, we record these heat pumps. So heat pumps is very efficient for if we can instead burning of fossil for generating heat we can use like heat pumps. So one of the example is your refrigerator. So geothermal heat pump use the earth or well water to providing heating, or it can be used for cooling, or also can using for water supply. The geothermal heat pumps moves energy from and to the ground, eliminating the outdoor equipments like attached in this normal air conditioning systems. The basic ground source heat pumps is that the earth loop is placed inside the ground, whether it may be horizontal or vertical, or it also can be placed in pond also. Whether whatever the you are available, what is the possible availability in your area, that is the that can be used. And this water loop that is inside this ground loop can be used normally use water with antifreeze solution. For this antifreeze solution, because there is some portion there can be solidified, that water may be solidified to the ice. So that's why antifreeze solution is mixed with this for not the phase change for not so that it can be phase change. So heat transfer take place instead inside the heat pump in a water to refrigerant. So here I am come to energy source. There is a energy source during the heating season. That means in summer, winter season, the earth serve as a heat source, with extracting heat from ground and supply to the room for room heating. And similarly, cold season, cooling season, the earth serve as a heat sink, that is extracting heat from room and ejecting to the ground. Now, how this heat pumps is operating? Each of these circuits, there may be four circuit that everybody are circuit are closed and sealed, and from the others there is no direct mixing. All the interaction of heat by this heat exchanger. However, heat does not transfer from this refrigerant circuit to the other three circuit. Refrigerant only working on this only the heat pump cycle. The refrigerant flow will change direction when the unit changes modes. That means same heat pump we can use for heating and for cooling purpose. Just we have to, there is a reversible switch. We can change the evaporator and condenser. This is the this main refrigerator circle which is run on the vapor compression refrigeration circle, and this is the earth loop cycle. This cycle, and this is the hot water circuit, and this is the distribution circuit. All of the circle are differently operated. Both are exchanging heat by this heat exchanger process only. So this is the schematic diagram of heating experimental rig. This is the for heating mode operation. So this is the main heat pump operation. There is a three circle, another three cycle. That is the water heater cycle. This is the air conditioning cycle, and this is the for ground circle. So for heating mode operation, that means in winter season. So cold water air is collected from this room through duct, and by exchanging heat, taking heat from this heat exchanger by from this refrigerant, and the hot cold air become warm and delivered to this room. And similarly, this cold water coming from, and it is extracting heat from this refrigerant and circle, taking heat from this refrigerant and delivering the hot water to the supply. Now this this where this heat is coming, which is supplying to this supply air and water. Now this what this is another cycle is ground circle. This is rejecting the heat. This water become cold. Now this cold water is circulating through ground and taking heat from this ground circle, and taking become this water hot. Now this water taking heat from this ground and extracting this through heat exchanger and delivering to this refrigerant. That is delivering. This is the heating mode. Now this cooling mode. Cooling mode that means for summer season. So summer season also water cycle is same for delivering hot water cycle, but this air conditioning cycle, this is required cold water. So taking the hot air from this room through this duct and rejecting this heat through the to the refrigerant and becoming cold. This cold air again supplied to the room. And here this taking the heat from this refrigerant, this ground loop taking the heat and water become warm, this hot water then again extracting heat to this ground. Now this extracting after rejecting the heat, its water become cold. Now this water is again circulating, cold water is again circulating to the refrigerant heat exchanger. Now the basic things is that why we are this using this, because the geothermal heat pumps can reduce energy consumption up to 44% compared with air source heat pumps. That means normal air conditioning is taking much more higher energy. It is taking less 40% less the energy, and up to 72% less energy taking for electric resistance heating. And the COP of this heat pump is 4.2 to 4.6 in cases. And if we using the cogeneration system, its COP can be 9. So this is the basic thermodynamic equation for COP heating and cooling. I'm not going for that. Now the discussion. The present worldwide installed capacity is estimated almost 12,000 megawatt, and the annual energy used is about 72,000 terajoule. That is 20,000 gigawatt hour. The actual number of install is around 111 lakhs unit. So here the maximum cases are installed is maximum the customer is that USA. USA is the most number is unit are installed. Nearly 6 lakhs unit are installed until that. Now, a small amount of electricity is required only to run the compressor, and however, the energy output is ordered to 4 times this input. Whatever the energy is taking for this compressor, and output is giving 4 times this the compressor. This 4 times through the output. The coupling of ground source heat pumps to the current UK current electricity grid, for example, can lead to reduction in overall CO2 emission over 50%. Whatever the install in UK, that can be reduced if we use this ground source heat pump. It can reduce the emission of 50%. Annual generation geothermal energy used at 72,000 terajoule, and comparing this to electricity energy generation using fuel oil at 30% efficiency, the savings are 35.8 million barrels of oil. This is the saving of about 16 million tons of CO2. The geothermal space conditioning system is reliable and durable up to the life. This ground loop can be sustained up to 50 years, and the heat pump can sustain up to 20 years life. The use of ground source heat pump can minimize the dependency over conventional energy resource, and this also decrease the emission of greenhouse gases. The ground source heat pump can achieve more COP than conventional AC, whatever the available in current market. In India, all space heating and cooling is done with the fossil fuels and air-to-air heat pumps. Huge amount of energy is used for space conditioning purpose. There are huge potential of ground source heat pump application in India to reduce the energy dependency over conventional energy source for space conditioning purpose, as also the help India to reduce greenhouse gases emission and leave a mark over global warming effects. So how area is required for installing this ground source heat pump is normally there are three type of system. We can see that horizontal, vertical, and slinky coil. For traces need 50 to 8 meters of pipe per kilowatt, or 10 meters of slinky coil pipe per kilowatt. So at least 5-meter distance between trenches with coils required. So for a normal household required 8 kilowatt heat pumps required, and this is required for 400 meters per grounded wide area for slinky coils. And if we go for the borehole needs, it's required 20 to 50 meters of pipe that is dependent on the soil condition, and for per kilowatt, and about 20 to 40 millimeter pipe are best for the performance. Now, for best condition for payback period, it normally cost is per kilowatt is 1.1 lakh to 1.5 lakhs per tons of capacity. Roughly, the estimated payback for optimal good condition is 2 to 3 years. It's make condition depends on a lot of other factor also, but it may 2 to 3 hours. So for other observation, the refrigerant are 4108 with the best for high pressure application. So this is up to 44 bar. The antifreeze monoethyl glycol 20% by volume used in ground loop for antifreezing. That's a and for backfilling of vertical loop, the paste of bentonite are used for
Ex-
better.
Excuse me, Rajat
Yes, sir.
ji.
Yes, sir.
You have left only 2 minutes.
Okay,
Okay.
no, sir. I'm
Okay.
just so my conclusion is that a ground source heat pump is the clean, reliable, and most sustainable HVAC system present in today's world and helping to improve the global environment. The benefits of doing harmless heating and cooling work with extend to the owner to the surrounding community, with which will appreciate effort to improve the sustainability. The initial cost of ground source heat pump is high, but the cost of electricity used to power a heat pump system is much more lower than the cost of the fuel in a standard system. So the payback period is 2 to 3 years. And rehabilitation of reservoir is carried out in the same area where heat is released or extracted. In addition, in double lead system and heat pumps, truly sustainable production can be achieved. Geothermal research can be therefore be regarded as renewable and in the timing of technological and social system. These are my references, and I would like to thank my PhD guide sir, Odis sir, and Nipen Mondal sir, and thank you.
Very good. You are within the time. You have managed your time very well, Rajat ji.
Yes, sir. Yes,
And
sir.
I would like to ask one question from you. What is the name of the antifreeze material you have used for your study?
Sir, we are studied on that. We only currently using this water only, but where this water, the temperature outside temperature is freezing temperature, then we have to use this kind of solution. Otherwise, in our Indian condition, only water, except Ladakh condition, the water is enough for experiment.
Okay, another question related with this only. What should be the thermal property of the selected antifreeze material? Means what will be the requirement?
Sir, the water does not go for the phase change. That is the
Yes.
main. property.
Yeah, nice.
So that means the
Thanks.
freezing temperature should be much lower.
Okay, thank you very much.
Thank you.
Any question from other side?
Okay, I want to ask him a few questions I have noticed. Okay. Okay, at first I congratulate Mr. Bhomik for this nice presentation.
Thank you, sir.
Well, and what is the cost effectiveness of this type of system in Indian scenario?
Sir,
I mean,
in
from
Indian,
economical point of view. What
sir,
do you think?
economical, I have told that the payback period is
Yeah, that
nearly
I
2 to 3
have
years
observed.
for a new
Yeah.
condition, and for new home. And if you go for the change of the current system, suppose your home has that air conditioning systems, and you want to replace this system, that may 4 to 5 years.
Okay. And what would be the costing of this? What do you
Well,
think? If you want to install this,
costings are nearly 10 to 12 lakhs.
10 to 12 lakhs.
And that is
Okay, well,
some depend on the ground. If you go for that borehole, then it will cost will be much higher than the other system.
okay.
That is
And what
vertical
ab-
borehole system.
and what about the COP? Is it so really high? I mean, that
So
is
normal,
six around.
no sir, that is other condition, depending on other condition,
Yeah,
that is
yeah,
the theoretical. Normally COP
exactly.
is 2 to 2 point something like.
That means considering the losses.
Yes sir.
So, what type of losses can you explain, please? Any idea?
um, there may be sir heat exchanger losses and uh,
Okay, then there may be some convection losses also from the borehole. Okay,
yes sir.
that. Okay.
Thank you
That's
sir.
a good presentation. Okay, if any other question from audience?
Okay, nice. If there is no question, so we may go
So
further.
next presentation. So you should
Next
go for.
presentation from
Thank you sir.
RE1552, Dr. Devajit Misra.
Yes, sir, I'm here, but
Okay,
facing some network issue. Uh, okay, I will start.
okay, just share your PPT.
Okay. Can you hear my voice, sir? Hello, sir.
Yes, your voice is broken. Sound is broken like.
Hello, sir.
Yes, it is coming now.
Hello.
Yes, carry on. Your voice is coming. Sometimes it is broken.
Okay, sir. Okay. So, I am Devajit Misra, presenting my article "Floating Photovoltaic Plant in India: Current Status and Future Prospect" from the roof. Thank you for your nice conference. Well, I would like to welcome all my session chairs and participants. Now, India is affluent with solar energy, and lot of work related to the solar photovoltaic technology is going on. And India also set up a big target about the solar photovoltaic technology by 2020. Everyone supposed to know it. It is around 175 gigawatt, and solar photovoltaic plant is 100 gigawatt. So in November 2020, this plan also changes, and it is now 223 gigawatt, about 40% of total traditional power generation. And within this, around 30 gigawatt is will be generated from photovoltaic plants. Sorry, is a floating solar photovoltaic plant and wind power. So thus, India keeps close attention toward the floating B technology, as there are many large water bodies which could be potentially utilized for large power generation. About the floating photovoltaic technologies, all over the world and present scenario at different places in the world, and study depict the which are already done and which are being working condition. Technical barriers and other challenges, because this photovoltaic technology is very 2008, and then it is fully implemented from around 2014. And thus, and study also evaluates the future prospect of a PV plant by utilizing large water body and reservoir, lake, etc. Because India have many water bodies and lakes, dams. It also evaluates the India's potential to develop 38.88 gigawatt capacity if we using only 35 large water bodies. So it is a case study. Now, solar PV technology implemented in a large scale everywhere in the installation of solar PV technology have a lots of limitation. Means regular solar PV technology, because regular solar PV technology requires 4 to 5 times more normal or traditional power plant. So in view of this, water surface is being utilization using a PV plant. Again, installation of land-based PV plant places should be plain and shadow-free. Okay, so wasteland or infertile land mainly used to convert this wasteland into power plant. Lot of effort is required to plane these uneven surfaces to even surface. So in regular rooftop or land-based solar PV plant, another big problem is the dust accumulation of solar panel, and cleaning problem is also there, because most of the solar plant in India located in south and western part, and this location remains with lot of dust. So cleaning and cooling is the vital parameter to maintain the efficiency of a plant. Thus, a PV plant can be used, because at PV plants there is always evaporative cooling, which also cool the plant. As land is scarce in India, and land is used for multiple uses like and certain settlement, and land acquisition is big problem here. Everyone knows that. Thus, solar plant located in western and southern part of the country. So this always around 35 to 40 degrees centigrade. So from the literature, we know that optimum solar power would be generated at a temperature of 25 degrees centigrade. And after 25 degrees centigrade, if temperature increases, there is a drop of efficiency, means electrical efficiency of the panel. So by the 0.5%. So using a PV plant could minimize this also. So India has a lots of lakes, large reservoir, hydro power plant, and floating big power generation could be the attractive on this. If we compare this regular plant to the floating solar plant, then India have a many large water reservoirs, so it could be utilized effectively. Floating PV technology is almost same as regular or only there is two different thing. One is a floating structure which is called pontoon, and the other is mooring and anchoring system which hold the pontoon and maintain the water level, maintain the floating structure when water level falls or water level rises. So these two things are only different than regular plant. Now, the benefits of a PV plant. Arable land can be conserved by the using of water body, because in water. So unused water can also be used for the power generation, renewable power generation. There is a no land acquisition problem. More power can be generated, as it already told that efficiency can be improved by cooling of the panel, and cleaning process is also easy. Water can be conserved by the reducing the evaporation, as panel is already placed in the water surface, so it reduces evaporation. So, and also reduces the draft nearby the area. Water clarity also improved, as algae formation do not happens in water surface. And though it has lots of benefits, but there are lots of challenges also. So as it requires lots of complicated design, and another thing is moisture content can affect the material or component of a system. A PV plant can be born of natural calamity like heavy windstorm, cyclone. Recently, not recently, 2 years earlier, one solar plant in Japan is breakdown because it is due to the natural calamity. Securing profitability is challenging task because cost per unit cost generation is more than regular plant, and durability is also and regular plant, and safe installation is difficult for regular. Problem aquatic system can be diverted because of globally technology from 2018, and 2018 it is under research for this period, and development and deployment of solar is very rapid post 2015. According to the World Bank report 2018, PV plant global is 1097 megawatt, and Asia is the possess leading position, and China is the leader. China is the leader. Other countries are South Korea, Taiwan, India recently employing the solar plant. Then Europe, UK, France, Italy, Netherlands, Belgium, Portugal, these are the major countries in UK. And in October 2019, France opened for their first floating plant of 17 megawatt capacity. Same time, USA opened 4.4 megawatt first floating plant in North America. Then America, Brazil, Chile,
Excuse me, Dr.
incorporating their
Mishra.
floating plant.
Excuse me, you have
Can you hear my voice?
Yeah, yeah, you have 2 minutes remaining. Okay, please make it.
Oh, sorry.
Okay.
Okay, I am just
Yes,
focusing my aim. So these are the present status of Indian floating plant. So figure 2 is the floating plant, which is first installed at Kolkata, Rajarhat, Kolkata. It is 10 kilowatt capacity in 2014. Then these are the plants in Kerala, which is installed at 2000 in 2017. Then here is another northeast, and here is Chandigarh. Here is some plants, Visakhapatnam and Nagpur, and project under development. Some project are under developing condition. Because of time bound, I can't explain all this. These are the projects which are under developing condition, under working condition, and some recent proposal, 8 recent proposal are be conducted, commissioned, and it would be implemented soon. Then future prospect. So as India is the third position in the world after China, USA in terms of number of dams, and National Register of Large Dam reported that India has 5,264 dams, and they are according to the reservoir of India, 56 large reservoir covering 1,14,000, sorry, 11,14,268 hectares, and there are other reservoir, medium and small reservoir. So I am just considering large reservoir whose area more than 100 kilometers square, and considering just of this reservoir from the literature, I found that 10 to 20 are considered for solar plant installation. And to evaluate the power generation,
your time is over
it is
now.
considered that 100 square kilometer
Hello,
required just
your time is over now.
100 square kilometer is required for the 1 kilowatt installation. And according to the another reference, so if I found that 1,700 500 liter
Dr. Mishra,
would
your
be
time
saved
is
in
over.
evaporation.
You
Hello.
should, Dr.
So
Mishra, you should
the
conclude now. Your time is over.
dam and
Hello, Dr. Mishra.
Hello, you are not audible, Dr. Misra.
Yeah, yeah, I think he is not audible. Maybe some network problem from his side. Dr. Mishra, are you there? Hello.
I think almost he has finished his work in his presentation.
Yeah, but I think he has lost the connection. Maybe.
Yeah. So we have to ask some questions, but we are not able
Yeah,
to
yeah,
connect him. So
yeah.
anyhow, when he will be available, we can ask some questions.
Yeah.
Right now, we have to move for another session, means another presenter. 1553 is also
I think he is
Devajit Mitra.
also Dr. Mishra.
Yeah.
1553. Yeah, so if he could not connect, then we should move for RE 1572 or what?
At that time, RE 1572 was not present. Right now, he is present or not? RE 1572.
RE 157. I think he is not responding. Yeah.
Hello.
Are you hearing? Hello.
RE1572.
Hello.
Are you there?
Are you?
RE1.
Yes, I am here. Are you hearing?
Okay, then you can share your presentation.
Yeah, you should start, Mr. Ali. You should start.
Are my slides are visible?
Yes,
Hello?
it is very much visible and sound is
Yes,
okay.
yes, these are visible
Okay,
and
sir.
sound is all okay. Okay,
Thank you,
please
sir. My
continue.
name is Abid Ali, and I am present my first paper on design and performance evaluation of box type solar cooker with energy storage under the supervision of Professor Naeem Akhtar in the MU College. As the time is very low, so I left the introduction part and directly start my work. Solar cooker. As we know, the solar cooker are of three types: simple box type solar cooker, parabolic solar cooker, and paraboloidal solar cooker. These two solar cooker can cook the food only in the daytime when solar is available, but not in the late hour of the day. So this problem can be solved with the help of introducing some kind of energy storage material. And according to energy storage material, solar cooker also three types: thermochemical heat storage system, sensible heat storage system, and latent heat storage system. Out of which latent heat storage system have 5 to 10 times more higher energy efficiency than sensible heat storage system. And these are the literature review according on the sensible heat storage system. Ramadan et al. Used a simple box type solar cooker and weld a pot below the absorber plate with half centimeter of sand in between the around the box, and reported that it gives the 6 hours of per day cooking, 3 hour daytime indoor, and 3 hour after the solar cutoff, and approximate efficiency of 28%. Vigneshwaram used material stored between a concentric cylinder of 2.9 kg of oxalic acid with simple box type solar cooker. And Domanaski et al. Used a simple box type solar cooker, and he replaced absorber plate with a step mirror which focus the solar energy in the between area of the box type solar cooker, and at a handle they place a pod double concentric cylinder pot. In between they use stearic acid and magnesium nitrate hydrate, and reported that it has 3 to 4 times more efficient than steam engine, steam and heat pipe solar cooker. And similarly, Sharma et al. And Budhi et al. Use a concentric cylinder with different material of 2 kg of acetamide, and Budhi used 2.25 kg and 4 kg acetanilide separately. And both reported that the cooking is possible if we load the cooker before 3:30 or 7 p.m. And Sharma et al. In 2005 uses the different technology they use. They collect solar energy at one point and transfer it to energy storage system at different part with the help of some kind of energy transport fluid. And they store energy in concentric cylinder with 45 kg of erythritol, and reported that evening meal cook at a faster rate, and the temperature of the inside the concentric cylinder remains 25 degrees up to the next morning. Literature gap between most of the researchers use a concentric cylinder with simple box type solar cooker, and and some uses the lower melting point material, and some uses the a complex system at Sharma et al. So, problem formulation in the market. Solar cooker, however, in the market have the opening on the front side. We fix this case with the box and provide a backside window for keeping and putting out the box, a cooking pot. Selection criteria. This is the selection criteria of the energy storage material. The melting point of the material is about 100 degrees centigrade, and the heat capacity in lower heat capacity in the solid state, so it can reach its melting point faster in less time. High heat of fusion, density or high density, so the system become more compact and low expense of the volume, and cheap and easily available in the market. Based on this criteria, we have two options. One is erythritol, and second is acetaldehyde. And these plot show the comparative behavior of both the material. Above the melting point, erythritol store more energy with respect to the acetaldehyde. So we select erythritol, and also it is very cheap and easily available in the market. For design, we design our box cooker according to the solar box, according to the BIS standard and solar box type specification, second revision of IS 134-29 second part. And the box cooker available in the market is aperture area of 0.25 meter square. And according to BIS, the cooker load is 8 kg per meter square of aperture area. And this is the design criteria of box our design. Aperture area of the cooker is 0.5 meter square. And during the design, display solar radiation is 700 watt per meter square, and we cut off the solar around 3 p.m. and the second meal is put up to the 6 p.m. and the maximum temperature that the observer attain during the charging in the daytime is approximately 135 degrees centigrade. Ambient temperature during charging 30 degrees centigrade, and during discharging cooker inside the room is 20 degrees centigrade. And the PCM, we use erythritol, which is a phase change material, so we called it this material is PCM. And the PCM quantity of PCM is calculated for the sensible heating of 4 liters of water from 38 degrees centigrade to 100 degrees centigrade, and plus heat loss to the surrounding. This is the exploded view of our design. This is the outer box body, is the observer plate, this is the PCM tray, and in between this is the energy storage material, and this is the insulation, and this is the double glass cover which fixed with the box body. This is the reflector mirror, and that is a reflector mirror case. We provide some insulation between the reflector mirror and reflector mirror case, which I explain later. Operation of the box type solar cooker. During the charging mode, energy received by the cooker, the amount of energy is supplied to the load. A small amount of energy is supplied to the PCM, and some amount is absorbed by the cooker interior, and some amount is lost to the surrounding. During the off sign hour, there is only PCM is the source of the energy, and this energy is supplied to the load, and some part of some lost to the surrounding. We check the thermal performance. This is the criteria for the thermal performance of the PCM cooker. We check the charging, check the performance according to the charging and discharging time, maximum temperature change, and storage efficiency, PCM utilization efficiency, and overall efficiency. This is the formula. The charging time of the PCM is characterized charging tau C is the charging time, and tau S is the sensible heating of the PCM from room temperature to its melting point, which is 118 degrees Celsius, and tau m is the melting temperature, melting time, melting duration of the PCM. And Q is total energy stored in the PCM up to the sensible heating, which can be after melting. Q in the incident solar radiation during the charging, and discharge. Q DIS is the discharging total discharging time. Now SC is the sensible cooling of the PCM up to the heating point if it achieves more than 118 degrees centigrade, and tau S is the sensible cooling time or solidification time of the PCM. This is the storage efficiency, is the total energy stored divided by incident energy, and PCM utilization and overall efficiency of the cooker. And a part of the incident solar energy is lost to the surroundings. So we need to calculate first calculate the loss of energy or overall heat loss coefficient. There is in this cooker energy in two ways, from the top and from the side and the bottom. From the top there is a two case. First is the charging mode. When the glass cover of the cooker is open, the energy is lost from the zero plate through the double glass cover only. And in the discharging mode, when the cover is closed and insulation provided in between the reflector glass and case, it closed the double glass cover. In the charging mode, we calculate the overall heat load according to Akhtar and Malik. According to the formula provided by the Akhtar and Malik, and it is charging mode, we apply the energy balance equation across the panel surface, such as observer plate to first glass cover to second glass cover, and so on through the insulation of the reflector mirror. And from the side and bottom, initially during the design, we don't know the thickness of the insulation around the observer plate, so we cannot use direct formula. So we use Fourier's law. We provide the heat loss coefficient as a function of insulation thickness, and this show the insulation variation of heat loss coefficient as a thickness of insulation. And with this function, we calculate the overall heat loss from the side and the bottom. And we also use the insulation between. We use this insulation in between the reflector mirror and mirror phase, which reduce the insulation thickness is 3 centimeter. We reduce the top heat loss from 2.88 to 0.96 for total heat loss. Reduce the total heat loss from half. We reduce the amount. We reduce the PCM required to store energy, and subsequently increase the duration of cooking off sunshine hour. This show the overall heat loss coefficient as the observer plate temperature. As a function of observer plate temperature, it is the overall heat loss coefficient during
Excuse me. You have just one more minute remaining. Okay.
Just show your result and the analysis, okay. Result analysis and conclusion.
Yeah. Okay.
Within 1 minute, you have to show everything.
This is energy loss after the calculation of overall heat loss or energy loss as a function of plate temperature. We analyze the feasibility of cooker as a function of charging time and discharging time. This is this analysis time analysis shows that recharging approximate 1 hour up to reaching 118 degrees and takes 6 hours to melting the temperature. And with heating of full load, it can solidify in 2.5 hours, and without load, it can solidify in 6 hours. This is the final design, and this is the comparison of and this is the comparison of standard cooker with the PCM cooker. And in this, the standard cooker achieve maximum temperature early with respect to PCM cooker, but second load achieve maximum temperature with respect to the standard cooker. Overall efficiency of the both the cooker are approximately same, and the second meal in the PCM cooker attain higher temperature. And this is and also we check the performance PCM cooker with primary and additional reflector. This is primary reflector and this is the additional reflector. And this show the variation of absorber plate temperature with time at about 3:40 p.m. the case of the cover of the cooker is closed and cooker is placed inside the room. After that, the temperature of the plate is decreased first and then increased up to a melting point, and after that gradually decreases and it remain about 100.
Hello, excuse me. Your time is over now. Abid Ali ji, your time is over now. We have to ask some question.
Okay, sir.
Okay. Have you carried out the cost analysis of
Yes,
this
sir.
system?
Yes, sir.
That
The cost of the cooker system is approximate 15,716. With additional reflector, it cost reached to 18,916.
And the comparison with the standard cooker?
With the comparison with standard cooker with continuous meal, we check it continuous meal. The efficiency of both the cooker is approximate equal.
No, cost. I want cost-wise comparison.
So cost per million. ये approximate point in market standard cooker is 0.25 meter square aperture area with cost of around 4,500 to around 5,500.
Only 4,000. And
Only
this system has around cost around 18,000. So it is costly as compared to a standard.
Double. We double the aperture area and also use the energy storage material. That's why it approximate 3 times.
Okay. Thank you. Any other question from Arjit Datta, sir?
No, my question was also that cost effectiveness.
Okay, thank you.
No, you have asked that. But I have only one, doubt. But is it so costly? Then what about the mass production cost? I mean, if you want to sell this for the local people, then
Hello, yes, sir.
you should think about the cost, and you have to optimize that. I think this is.
Yes, it can be optimized. We make only one piece, so the labor cost is much high. Labor cost is approximately 3,000 to 4,000. If you go on mass production, then labor cost obviously decreases. It can be reached to 1,500.
Okay. So I don't have any question.
This way, cost comparison approximate 2.5 times.
Okay. So if the audience has any question, and if not, then we should go for the next.
Next, we can go for the next. Dr. Debajit Misra has not concluded actually.
Exactly.
Second paper also 1553.
Yeah, he has another paper.
So if he is available, so we can invite him, Dr. Debajit Misra.
Yeah, he's there. Is there, Dr.
Okay,
Misra?
okay, sir. Because of network issue, I can't complete.
Yeah.
Complete.
So I
just
have
carry on.
I have just one question to Dr. Misra.
Okay, sir.
Say for that your floating photovoltaic plant, okay, that is installed in the water body itself, okay? So what about the ecosystem of that water body? That I want to know. Is it being harmed or disturbed, or what is your conclusion?
Actually, I am go through the literature and found that if area accumulation is much more, then it would harden the ecosystem, means aquatic system. Okay, so that's why I am considering just 10% area, and if some fountain or some aeration system, means air whenever air is passing through the water, then it could not harm water ecosystem, I think. And the area is just 10% of this, actually it could not harm, I think.
And my another question is that in a small scale, is your floating photovoltaic plant is applicable in hilly areas in India? I mean, in a small scale, because
Small scale, already in Manipur, there was a plant already coming.
yeah, that's why I'm
It is
asking.
possible in
Yeah,
lake
yeah.
area.
Because
Always,
water body area is less
Yeah.
in hilly section,
Yeah,
so
that's why.
a small scale will be possible. But
for small
whether,
scale it is
Small scale.
possible.
yeah,
Large scale it can't possible.
Yeah. Okay, I don't have any question. If anybody have any question.
okay, no, I have not question. So we can move for another paper 1553 from Dr.
Exactly.
Devajit Misra.
Okay, please.
Okay, sir. Okay, sir. So, can you see this slide, sir? Hello, sir.
We can see, we can see.
Okay, okay, okay.
Just enlarge it.
Now I proceed.
Yes, please
Okay.
zoom it.
Uh, okay, okay.
You will be given only 10 minutes, Devajit Misra, if you don't mind.
Okay, sir. So I am now presenting another article, feasibility study of floating photovoltaic plant at Mukundpur in West Bengal, India. Now, present day solar photovoltaic plant is a most promising option in terms of renewable energy, and floating photovoltaic is new technology, so which could also be now enlarging entire the world. So that's in that sense, I am covering this thing. So the study is done on
Excuse me,
Mukutmanipur
Doctor.
because I
Excuse me, Doctor
have
Misra. You should
hello, hello.
click on your slide. Only this.
You have not shared your PPT.
Yeah. He's not sharing his
Oh,
PPT.
okay.
Okay, please.
Okay. So give me some time. Stop presenting.
I think you should click on the PPT. Your screen is sharing.
There is
You have to open it first.
okay.
No, you share screen and click on the PPT. You're sharing screen, but you're not clicking or opening the PPT. I think that is the problem.
Sir,
There is some
Actually,
technical
mine-
issue, so we can move
Yeah,
to another paper.
okay, sir. Give me at last, because my laptop is also not working properly, I think.
Okay, no
Okay,
problem.
you
Paper
will be given last.
1573 is present. Paper,
1573.
yes, I present.
1573.
Yes.
Okay, please share.
Should I start, sir?
Yeah, you can
Yes,
start.
please.
1573.
Okay, thank you very much. My name is Naeem Akhtar from Department of Mechanical Engineering, AMU Aligarh. In this short communication, the topic of the paper is effect of top heat loss coefficient on useful energy of double glaze flat plate collectors and the existing correlations, of course, of the top heat loss coefficient. We all know that the useful energy from the solar collector is available after meeting the heat losses. And the computation of heat loss from the collector is essential for the design or simulation of the performance of solar collectors. And in the applications where the required plate temperatures are higher.
Your video is not on. As well as you have to share your PPT.
Oh,
PPT is not shared.
okay, just wait. PPT is not shared. Yes, share present now. Bismillah. Should I start now? Is it visible? Is it
Yes, but
visible?
Yes, it is
visible, but
visible.
make it a slide so or zoom it.
Okay. Is it okay now?
Yeah, it's okay. Perfect.
Okay,
Perfect.
correct now.
Thank you very much. Thank you very much. Now, my topic of presentation is the effect of top heat loss coefficient on useful energy of double glaze flat plate collectors and the existing correlations, of course, of the top heat loss coefficient. We all know that the useful energy from the solar collector is available after meeting the heat losses. So the computation of the heat loss from the collector is essential for the design or simulation of the performance of solar collectors. And in applications where the required plate temperatures are higher, for example, in the box type solar cooker or for the flat plate collectors applied to vapor absorption refrigeration system, in these cases, the required plate temperature are higher, so double glaze collectors are preferred. So the calculation of heat loss, actually this is the useful energy which is available after meeting the heat losses. It is the energy absorbed minus the heat loss. Energy absorbed is optical efficiency and multiplied by the intensity of solar radiation which is available, minus ULTP minus TA, the basic formula, where UL is the overall heat loss coefficient, which comprises of the top heat loss, bottom heat loss, and side heat loss coefficients. And we all know that the bottom and side heat losses are very small. So the main contributor is very small, 10 to 15% in a well-designed collector. So the main contributor is the top heat loss. So if by selecting the improper relation for the calculation of top heat loss, if an error is made in the calculation of the top heat loss coefficient or the heat loss, there will be error in the useful energy. And this error will be higher. We can see from this figure, which shows the effect of the top heat loss coefficient on the useful energy. For example, we are having a double glaze collector where these are the parameters of the collector. Intensity of solar radiation is 600 watt per meter square, which is reaching to the absorber. That is optical efficiency into I is 600 watt per meter square. So in this case, if even 10 to 15% error in the calculation of the top heat loss coefficient will make large error in the calculation of the useful energy. Similarly, if the absorber plate temperature is higher, which is of course required in case of the application where, for example, in vapor absorption system or the solar cooker, the resulting error in the calculation of useful energy will be much higher. Similarly, in another case, two intensities of the solar radiation which is reaching to the absorber plate has taken, and we can see the effect of any error in the calculation of top heat loss coefficient on the calculation of the useful energy. So this is very important to calculate the heat loss coefficient. So the heat loss coefficient has a strong effect on the calculation of useful energy delivered by the solar cooker. Even a moderate error in the estimation of top heat loss coefficient can result in substantial error in the prediction of collector performance. And erroneous conclusions may be drawn due to incorrect estimation of the top heat loss of the heat loss coefficient. Top heat loss coefficient of the double glaze collector. This is the thermal network, and this is showing the insulation at the back side and absorber plate, first glass cover, second glass cover. We know the heat loss is in the upward direction. That is the top loss by convection and radiation, and this shows the right hand side, it shows the thermal network. And the basic equation, the governing heat balance equations from absorber plate to the first glass cover, similarly from first glass cover to the second glass cover, and second glass cover to the atmosphere. And these heat transfer coefficient, which are radiative and convective heat transfer coefficient, the relations which are available in the books. And this relation is for the natural convection between tilted layers, which is given by Hollands. Another relation also available in the literature by Bushberg, that is called the three-region correlation. So for the calculation of the top heat loss coefficient, there are two methods. Either one has to go for the numerical solution of the above heat balance equation, which we have just seen, or another way is just to estimate the values of UT from the approximate relations which are available in the literature. The approximate relations available in the literature, very old relation by Klein, when there was no relation available and it was very difficult to make a computer program. The first relation, this was due to Klein, it was pioneering work at that time. Another relation is by Agarwal and Larson, and then in 1981, then another relation by Malhotra et al. Several relations are available. Then an analytical form of equation is given, because in the previous equations we can see that the convection and the radiation terms, these are not in order as we have seen in the thermal network. They have been regrouped and somehow it calculates the top heat loss coefficient for certain design parameters of the collectors. Although the collector is having so many variables and it is covering a large range, and this relation, that is the approximate relation, this fails in that condition. So another relation, analytical equation, was given by Samdarshan Malik, and for this, as the glass cover temperature is not known, simple relation which are approximate for calculation of the second glass cover and first glass cover was given. Although these relations for the top glass covers are approximate, but it calculates the top heat loss coefficient with little accuracy compared to the empirical relations which were available earlier. Another relation was developed in 2007. It is in the Journal of Energy, and another relation for the calculation of the second glass cover and first glass cover is given, and using the analytical form of the equation for UT is calculated. And here the values of the UT obtained from numerical solution are compared with the values obtained by the relations just we have discussed. So the values of top heat loss coefficient with absorber plate temperature, this variation is shown in this figure, and the value of the numerical solution, it lies here in the middle. Some of the equations they are giving lower value and some are giving at the higher side. If we see the variation with other parameter, the nature is totally different. All these relations are giving lower value, and only two relations they are giving very close value to the numerical solution, that is reference 6 and 7. Similarly, we can see, if we see the percentage error in the calculation of UT using different correlations for the top heat loss coefficient, we can see the two relations, that is reference 6 and 7, they are giving the values very close to numerical solution. So it is just with the x-axis is giving the value, and other relations they are giving the values with some error at some point, and they are giving true value with that is coinciding with the numerical solution with certain combination of variables. Similarly, we can see that in this figure also, the percentage error in top heat loss coefficient with the inner gap air spacing is shown here. We can see some of the relation they are giving the very correct value, that is error is 0%, but it is for certain assumed values of the design parameters of the collector. For other parameters, they are deviation is much higher. So we can see that these values, since in these figures only one variable is taken at a time, the results shown in the above graphs represent the effect of
Excuse
two
me,
variables.
Dr.
Yes,
Akhtar.
yes.
Excuse me, Dr. Akhtar. You have 1 minute remaining. Okay.
1 minute. Oh, okay. Just I am going to finish now.
Okay.
Well, 1 minute. So in the graph, we have seen that the variable of at a time, one variable or two variables are shown. If we analyze taking all possible combination of variables by varying each of the variables in a small step, we have and covering the large range of variables which is shown here for the collector, it is seen that the reference 6, this is reference 7, it is giving the values very close, that is within 1%, and reference 6, it is giving the values within 4% with the as compared to the numerical solution. Whereas the empirical relation, they are giving much more error, maybe 40%, 50% for certain combination of variable. This trend is we have noticed in the above figure 4 to 6. So these are the conclusions. Just I have discussed it, and the same is written under the heading of conclusion. Just I have discussed it, and these are the references. So since the time is up now, any question, please?
Okay, thank you, Dr. Akhtar, for this nice presentation. And you are doing research in this, I mean, convection fields. Okay, so I have just one, not question, a doubt.
Yeah.
One of your numerical correlations, you have shown that
Yeah.
the range of the Rayleigh number is less than 10 to the power 6. But suppose if in any highly turbulent cases,
Yeah.
if it is greater than 10 to the power 6, then what would happen? So
Actually, in the solar collector inside
yeah,
this Nusselt number is this relation is for the tilted layer between two parallel plates. So this is natural convection
yeah.
between the absorber plate and the glass cover, or between the two glass covers. So the
Exactly.
Rayleigh number is in that range. I have checked it, that what is the range of the Rayleigh number.
I mean, it is comfortably within 10 to the power 6 that you have.
Yeah. Because
Yeah,
the
no,
yeah, because
yeah,
it is
and
natural convection. Natural convection is between the parallel
exactly,
plates. Yeah.
exactly. So you are doing this because natural convection is a much more complex thing. So you are doing this research. That's very good. And that's impressive. Okay.
Thank
I do
you,
not
sir.
have any
Thank you.
questions. So
Thank you.
if anybody has any
Anybody,
questions.
yeah.
Okay, very good, sir. Thank you. Thank you very much for nice presentation.
Thank you, sir. Thank you, sir.
So we should go for, I think, RE 1576.
It is 1576, correct?
Yeah.
Yeah.
Yes, sir. Good afternoon, sir. I'm here, sir.
Yeah, you are there. Okay.
Yeah.
Good afternoon. Good afternoon.
Good afternoon, sir.
So we have
So
10 minutes time.
Yeah, I think Naeem sir has to stop presenting for me to start presenting.
Okay.
Yeah,
Okay.
I should stop. Yeah, thank you. Thank you. So I have stopped it.
Okay.
So, good afternoon, everyone. Good afternoon, respected chair. Good afternoon, coach. So my paper is a study paper on shifting the focus from macro to micro waste to energy WTE plants as a solution to solid waste management. So just for an introduction, I've just shared a picture whereby I tell you that urbanization and waste, they go hand in hand. As the speed, hello, as the pace of urbanization goes on, the amount of waste generated also increases. We know that world ecology is a fragile one, and out of all the waste disposal methods which are carried on, landfill is the most common of all. Two major problems with the landfill is one pollution, and the other one is the requirement of land. WTE, waste to energy, has been an alternative which has been explored and successfully implemented in some of the development countries, and it is also being explored in a lot of the developing nations, with China leading from the so-called second-tier nations. And as an introduction, I'll also tell you that the potential of WTE has been researched at 2,539 megawatt, with the total waste generated at present at around 127 kilotons per day. It is estimated that with the pace of growth and urbanization that India is in, by the year 2041, it could reach around 4.4 lakh tons per day. That's quite astronomical. And for the efficient use of WTE, two things are the major requirement. One is the extensive study of the incoming waste, the waste generated, and the proper and effective management of the waste segregation. It is being developed at a rapid pace in India also, with the government of India investing a lot on WTE technologies. Uh, when we are developing a system, we may be able to develop a system which is feasible, but this is again concentrated on a larger cities. However, as we know, India is a very diverse country, and it consists of a lot of small cities and towns, small upcoming towns, in which the waste management is still at its infancy, or we can even say that it is non-existent in some cases. There could be a solution whereby we could develop a micro level WT, which is being established and operated by small communities and institutions, rather than giving it a label of an industry where you need a large plant with large amount of management resources required. So this study, we try to investigate the feasibility of a micro level WTE plant. Thereby, the motive would be to reduce the amount of waste which is being just sent to landfills. So thereby, we reduce the burden on the municipalities and the government for the waste management of it. So with the literature review, there are a few things which I found out. Uh, Waste management, as I've been highlighting, has major issues right now, and it depends a lot upon the improper waste infrastructure which is there and the informal sector. The informal sectors being the rack pickers and the scrap merchants. One of the major issues with the waste management in India is there's a there's a lack of responsibility which is shown by the community towards the waste. So community, the current status of waste management in India is extremely poor.
Excuse me, Naeem Akhtar Khan, mute yourself. Name Akhtar Sahab, mute yourself. Mute yourself.
Okay.
Okay,
Thank
I'll
you.
carry on now.
Yeah, carry on.
One of the major issues with waste management in India is that there's a lack of responsibility which is shown by the community towards the waste. The current solid waste management in India is very poor because we don't follow the appropriate waste disposal methods. There are a lot of reports which is being carried on and which has been published. One of the report in India UK seminar report by the Sustainable Solid Waste Management for the Cities is highlighted that the track record of India's large-scale MSW incinerators, which is the predominantly used incinerator plants in India, is it's very poor. The first MSW incinerator plant, which was built in Timarpur in New Delhi in 1987, it was shut down because of the poor waste segregation. As I highlighted previously, one of the major components of it being successful is the segregation of the waste. Due to the poor waste segregation and due to the erratic nature of the waste composition which is coming in, the rate had the New Delhi plant had to be shut down. There was another blog which is published by the University of Science, California, USA. It also showed the newest 3 WTE plants, which are in Okla, Gazipur, and Bhawana in New Delhi. They have been notified by the Green Tribunal, with a case being registered at the Honorable Supreme Court for causing pollution. Now, that is a little thing that is because we wanted to reduce pollution, but it is again causing pollution. It was found that rather than using a RDF fuel, which is derived from the industrial and commercial waste, they were directly using the waste MSW, which was untreated. So thereby MSW itself in India has a very low calorific value, and it is not self-sustaining. And the combustion is not self-sustaining, and the result was there was a lot of toxicity in the emissions. And then there are a lot of studies which has highlighted the failure of the large-scale WTE plants in India, and it has not been successful. That the large-scale WTE plants have not been successful in India. It's being a result because the technology which is used, I have not said the technology has failed, but the technology which is used is not proper to the waste that is being generated in India. It is crucial to check the incinerability of MSW and the amount of waste generated in large scale in WT. It has to, for the WT to be feasible, the amount of waste generated also has to be large if you're talking about a macro style WT plant to generate electricity. The choice of WTE technology largely depends on a composition, on the composition of waste. And composition of waste changes from region to region. And it also a lot of change owing to the seasons. Okay, in general, the MSW in India has a large amount of organics, 51% organics, with recyclables at 17.5% and inerts at 31%. There was a study done on the open dump site in Chennai, whereby they saw that 35% of the waste had a potential of being composted. 30% waste could have been recycled. So thereby itself 65% of the waste could have been reduced if the segregation and the planning would have been proper. This open dumping is very predominant in India, as we are aware, and this creates a lot of environmental pollution. It can be reduced to some degree by the awareness from the producers with the proper segregation methods. The scenario of MSWM, that is Municipal Solid Waste Management, is very poor in India. A study has reported that the urban local bodies, none of the urban local bodies in India are ready to implement the MSWR rules of 2000. They have also stated that there are no ULBs in any city which can claim for 100% waste segregation at the producer level. So out of the total waste collected also, out of the amount of total waste collected also, only 12.45 or 12.5% of the waste is properly scientifically treated. Rest, it is just kept as open dumping. So just a brief of the prevalent WT technologies. We have a biochemical conversion, which is like the biogas, which is very predominant in early rural India. So it comes under biochemical conversion. It requires a very high moisture content. There are 2 types
left now.
So I'm about to finish. There are anaerobic digestion and fermentation. So those are the two main things. And in thermochemical, which is the most predominant WTE technology in the world, there is combustion and incineration. We have gasification and pyrolysis. And I'll just give a small concept of microgeneration of power. It is defined as power which is generated and at the place where energy is required or at the source. Microgeneration of power it is defined that the power cannot be used to feed the national grid. Okay, there are many models of establishing this microgeneration. The necessity of micro level WTE plants, as from the little bit of research that is being done, the managing of a large scale WTE plant is very, very difficult because it requires a large amount of capital. Technology selection has to be accurate. Operation of the plants again depends upon efficiency of the workers and the segregation of the waste which comes in. The segregation of waste in India is not an easy job because India is a huge country. So segregation of waste is not possible. So if it is not done at a producer level, then it will only add to the additional cost. Necessity of micro level WTE plants. When the target of waste segregation is limited to a small community like housing complex, small, we have an own structured society. So the responsibility of waste segregation of the producer can be easily passed on. Okay, so take for example, we live in a small community, it can be easily passed on. So there was a lot of research also being done on WTE plants at a small level. Like there are few cities, there was a study made on few cities on the name it named as Forum of Cities that Segregate. They've declared that small cities are more efficient in waste management. There was a success story of Bengaluru in Sindhura district in Maharashtra with a population of 18,000. Under leadership of the city officer, they transformed from a land-filling town to a revenue generation one.
Your time is over now.
Okay, sir. So there was a 95% waste segregation.
Yeah,
There was
time is over.
another one. I'll just take 30 seconds. Sir. It's about to finish.
Okay.
There was another word, Surya Pit. Okay, it was the same thing. So what we concluded, what is comparatively easier to replicate these successes in a micro level than at a macro level, because India again is a huge density, huge population density and rapid growth. So if we take the responsibility at the micro level, it is much easier. So here we have tried to in a picture of alternate solution to waste management by shifting the focus from macro to micro level. Thank you. So these are my references.
Okay, that's a nice presentation. So I would like to ask Dr. Sanjay Singh sir, if you have some questions.
Yeah, it is a nice presentation. Means survey kind of
Yeah,
paper,
case study.
study,
Very
case
good.
study. So it's good means collection of data. So nice. I don't have any question right now. Okay.
Yeah. So me too, I do not have any question, but so audience, if they have some questions, or otherwise we should carry for the next RE1582, I think.
Yeah, 1582.
Yeah.
Thank you, sir.
Good afternoon, sir.
Good afternoon.
Yeah,
Good
this is
afternoon.
Prashant Mavle.
Yeah.
Okay.
So you should share your PPT.
Yes, one second.
And you have 10 minutes.
Yes, 10 minutes only.
10 minutes.
Sir, are you able to see?
No, we are not. I think PPT is not visible. Dr. Singh, can you see? Or
No,
anyone?
it is not visible.
No, yeah, it's not visible. I think you share the screen and click on the PPT or open the PPT, then it will be visible.
Sir,
Okay, your screen is shared.
okay, sir.
I think it becomes a loop.
Yeah.
So you should log out and log in yourself for better. I think
Log out and log in.
And then share your screen and click on the PPT. I think it would be better.
Yes, it is now coming.
Now it's visible. So just zoom it or make it a slideshow, then it will be clearly visible.
1 second, sir. Are you able to see now? Hello?
Yes, now it's clearly visible.
It's okay now.
Okay, sir. Okay. 1 second.
Just click on slideshow. Okay.
So, good afternoon, sir. This is Prashant Mavle. My topic of paper is Energy Management of Indian Grid by Transmission Line Maintenance. So, abstract of the paper, sir, is maintenance of transmission line as important factor for energy management. Theory implemented for maintenance is by minimization of various types of faults that taken place on the transmission line. For this, I am using various inspecting equipment as a condition monitoring equipment for transmission line maintenance. Here, the basic requirement for transmission line maintenance under various fault conditions are studied in this paper. And this paper also presents a case study of 400 kV AC system of Indian grid under trip condition with observation and various analysis. And I suggested live line maintenance work is the suggestion for the most common problem for continuous energy management. My contribution for this paper is transmission line outage under pre-fault condition can be detected and proposes required maintenance strategy for minimization of outages. The proposed methods are effective in detecting and identifying pre-fault condition and related maintenance. The keywords for the paper are energy management, maintenance techniques, and condition monitoring. This paper is aiming to discuss manage continuity of supply by early detecting various line faults and its causes, conditions, classifications. Paper shows energy management of transmission system and outage showed with various maintenance work. They are related to each other. Minimization of outage by various test method and maintenance techniques. Proposes live line maintenance work for some faulty conditions. Live line maintenance technology has opened the way of energy management by cost saving and life extension of transmission system. And this paper shows the application of inspecting equipment as a condition monitoring equipment to decide the maintenance strategy, which type of strategy we need to apply. So some steps are shown here for energy management. The important steps are: first is metering energy consumption and collecting the data. Second, finding the quantifying opportunities to save energy. Third is targeting the opportunities to save energy. Fourth is tracking your progress at saving energy. So these are the steps required for energy management. And maintenance technologies are used on these following criteria. First is operating criteria, climatic criteria, technological criteria, organization criteria, functional criteria, integrated management system, and economic criteria. Here, for this paper, what are the equipment used for the patrolling under fault condition or before fault condition are thermographic scanning, UV image corona inspection equipment, cable height measurement meter, PID, that is puncture insulator detection using positron instrument by electric field measurement, PID by voltage measurement method, tower footing resistance method, tan data measurement of CT/PT, capacity voltage transformer, reactor, grading capacitor, etc. So these are the equipments which we are using for inspection purpose. And again, so all these types of faults can be identified by categorizing as different condition, different we can say types, that is line to ground fault, line to line fault, double line to ground, three-phase short circuit, and triple line to ground fault. All these faults are depend on voltage and its post clearance. These faults are measurement and depending on the current flowing at different conditions, that is, we can say final state of current and present state of current. By identifying the difference between that, we can find out the change in current, and by identifying change in current, we can decide whether this is a pre-fault condition or full fault condition. Then by identifying the change in voltage, that is V fault max upon V pre-fault condition, and again we can find out the RMS value of current at different condition, that is I1 of n minus 1 minus I1 of n, where the n minus 1 is the precondition and I1 of n is the final condition. So every situation we need to find out the per phase value of line current and phase current. Similarly, we need to find out the per phase values of voltages and the phase angle between voltage and current. And all these factors are depend on the how much variation is there. So for the pre-fault condition, we are considering if the current is more than 5% of normal. Similarly, frequency is more than 5% of normal. Then voltage is more than 5% of normal that we are observing. And here it is shown that the fault is taken place on the Y phase, and accordingly it is shown by the change in current as compared to pre-fault condition. If you see, here is the pre-fault current and here is the fault current. So magnitude of fault current is changed under this both the situation. It is shown by the red waveform on Y phase. So here also the fault initiation is shown on this time and magnitude of current diagram. So it is the minimum fault initiation, or we can say fault initiation stage. This is maximum rate of change of current, and this is the settling. Again, the types of faults which occurs on the transmission line are shown here. Phase to ground fault is the maximum type of fault occurs, that is 70%. And the mainly equipment failure are insulator fittings of hardware, switching surge outage, lightning surge, conductor break, bad weather condition. And least fault occur on the transmission line are three-phase failure and three-phase short circuit fault, only 2%. Here thermographic scanning is used as the inspecting equipment on the lightning arrestor is shown here. So here we can see a hotspot. We are identifying where we can detect the temperature, which is indicating that there is some loose connection or some maintenance is required at that particular point. Then corona inspection we are identifying by UV camera image, and accordingly we can decide which type of insulator disc are going to be damaged. So here, what are the inspection and testing work done by a line of 400 kV for Maharashtra units are shown here. Here, what are the testing are shown for the year 2016, 2017, 2018, and 2019, and accordingly the graph indicating that number of inspection work and testing works are carried out on a 400 kV line. So here person are removing the damaged insulator string is shown on this picture, that is replacement of insulator string by live line technology. Here if you see the
excuse
supply
me, time is up now.
Yes sir, supply in the line is going on
now. Only 30 seconds left.
Okay, here jumper is shown here. Again here present the case study in which we can identify this condition why the line fault occur, and here I suggested the live line maintenance, and by finding the pre-fault condition we can minimize this fault. So here again it is showing by the waveforms, which waveform are indicating the conditions of the current and voltage under fault condition. So these are the references. So here I proposes the level and maintenance and pre-fault condition study to identify the fault, and by taking the proper inspection, we can take the decision so that we can minimize the fault and save the, we can say, outages. Thank you very much, sir.
Well, that's a good informative case study, I think. So I have just one question. So you have explained everything about the overhead transmissions line inspections like that. But what about underground inspection? Can you tell me about something?
Sir, underground is also there, but for that we need to require some, we can say, underground test cables are there. So in that underground test cable, we are not having that different types of fault which are depending on the atmosphere actually.
Okay.
Underground faults are taken place only due to the digging of the some of the, we can say, malfunction, or we can say maybe after some duration of time, maybe 25 year or 30 year, and maybe you can say short circuit taken place at some of the areas. But on overhead voltage, or sorry, the lines which are atmospheric to the open area, so they are more prone to the different surroundings, and hence we need to take the maintenance. So it is
Okay.
suggested for that area, sir.
Okay, Dr. Singh, if you have any question.
Yeah, one question that is not related to this topic actually. I want to know some equipment regarding condition monitoring which is being used in rotating elements, जो rotating parts जो that is available means होता है machines में, उसके लिए can you give some names of that condition monitoring equipment? Like there is turbine shaft, like there is a compressor pump shaft like that.
Sir,
So
for actually, as I am the person from electrical point, we are
yeah.
having phasor measurement equipment, phase integrated relays there actually.
Okay.
Whenever we want to connect this grid to the transmission line, so we need to check the voltages, currents,
Right,
and
right.
the phase sequence actually. So there is phase sequence relay actually, which is measuring the phase sequence of incoming line and the grid, and accordingly it is observing actually.
Right, right. Okay, no problem. Thank you. Thank you very much.
Thank you very much, sir. So may I quit, sir?
Yeah, you can quit.
Okay, thank you very much, sir. Thank you very much.
One paper is remaining right now.
Yeah, Dr. Mishra,
Dr. Mishra.
RE1553, I think.
Yeah.
Yeah, so he's there, I think, Dr. Mishra. Dr. Mishra, are you there?
I think he is not here.
Only his paper is left, I mean, RE1553.
Yeah. So what to do now? Whether we have to wait or...
I think we should wait for our session co-chair, Dr. Arghadip.
Yeah.
Dr. Arghadip, are you there? Dr. Mishra?
His telephone number, mobile number is not available. Otherwise, we can call him also.
Yeah. It is not available. So we can message to the WhatsApp group. That means RE1553, please join session 6 immediately.
Yeah.
Let me.
Yeah, please.
Okay. Let me do this. I have message to that group.
Okay, we will wait for a few minutes.
I mean, I have message that RE1553 session 6, please join immediately. So
After waiting 1 or 2 minutes, we can conclude this
yeah,
session. Yeah.
yeah, but Dr. Arghodip, yeah, Dr. Kundu. So what should
Yes, sir. Hello.
what? Yes, Dr. Kundu,
Are
can
you
you hear
listening?
me?
Yes, yes, yes.
Yes. So
Yes,
what
sir.
should we do now? Because Dr. Mishra is not joining, and I have messaged that in the common WhatsApp group.
No, Sandeep Kumar replied, sir. Okay, I said replied.
Dr. Devojit Mishra, his paper is remaining. Dr. Devojit Mishra, RE1553. His one paper he has presented and another paper is there. And he is the remaining one of this session.
So he's not there. So
But he told a few minutes ago that he has some problem with his laptop or maybe. So
what to do now, sir?
should we wait for another 2 to 3 minutes? What Dr.
Okay,
Singh
okay.
said?
It's okay. Whatever
Yeah,
you
we can wait for 2 minutes, another 2 minutes.
Yes, 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 sir.
Yeah. Yeah.
Okay.
And moving toward the applications are like pattern documentation, matters calculation, auto association, time installation, and these are the applications. I'm going to this slide, ceramic so moving on photoceramic matches, here we have user combined photorealistic problem is considered to detecting the photoceramic matches. And the problem was solved by user finding one temperature profile for solid and gas phases. To compute solid and gas phases.
Hello, sir. I don't think he will come.
Hello.
I don't think he will come.
Okay,
So
okay.
should we conclude the session?
Yes,
Dr.
yes,
Singh?
sir. Please conclude. Please.
Yeah, we will conclude now.
Okay, so this is a very nice presentable session of various topics. So, and I thankful everybody to organize this beautiful conference, international conference and session. So over to Dr. Singh.
Yeah, it was a very nice session actually,
Yeah.
and all paper were very beautiful, and they have presented very nicely, and quality of
with in time and
yeah,
case study related and very
yeah,
nicely presentable.
and we are very much thankful to
Yeah,
Arjit
very
Kundu
much thank.
Sahab, Professor Arjit
Dr.
Kundu.
Kundu, Dr. Kundu.
Yeah, Dr. Kundu sir is available here. We are very much thankful for arranging
Give us
this
this
type
honor.
of international conference. So, okay, thank you very much.
Thank you.
And
Thank you very much, sir.
It was
very well. Thank you very much, sir.
It was nice session with Arjit Datta Sahab. So,
Thank you, Singh sir.
Thank you very much.
Okay,
sir.
Kundu sir,
Yes.
I'm going to send the marking email after a little bit time. Okay.
Yes. Please give it to my email, our email, conference email, or to my WhatsApp number directly.
Okay, no, that is from that email ID. I have received that. What?
Yes.
Yeah. I'm sending that.
Thank you,
Okay.
sir.
so we have to give separately or one marks.
You can give it anything. You can give it separate. You can give it as a whole. Whatever you want.
Okay, we will discuss. Yeah.
Dr. Singh, I think we should give separately and let them make this average on what.
Okay.
I think it will be better. Okay.
Yeah.
Yes, sir.
Yeah. Thank you.
Okay,
Thank you.
Okay, sir.
Okay,
Thank you very much, everyone.
should I log out? Okay.
Yes, sir. Yes, please, please.
Thank you. Bye.
Okay,
All
thank you very much
participants. Bye.
for giving me this opportunity. Okay, Dr. Singh sir.
Yeah.
Okay,
Bye.
Dr.
Bye.
Kundu
Thank you.
sir. Bye.
Good evening.
Bye.
Yes, sir. Bye, bye, sir.
Have a nice day. Bye. And have a
Thank you.
nice
Thank you.
and
Same
have
to
a
you.
nice conference remaining.
Yeah. Thank you.
Okay.
Hello, sir. Actually, my network is off at that time. Could you?
Okay. 1 minute, Singh sir. Dr.
Yes, sir.
Mishra is there, I think.
Yeah. I am here only.
Sir.
Yeah, I'm here also.
So, Dr. Devojit Mishra has come, sir.
Yeah,
I am
yeah.
here.
Sir, due to my network issue, I face lots of problem.
Okay.
Yeah.
Okay, so are
We
you
are.
able to present now?
Okay, sir. I'm presenting now.
Just
Sir,
present,
So,
please.
I'm
Okay, it's okay.
presenting now. Could you? Okay.
okay.
So here is my article: feasibility study of floating photovoltaic plant at Mugumunipur in West Bengal, in India. So we know that solar photovoltaic technology is promising option in terms of renewable energy all over the world. So that's why I am interested to give a case study here, installing 310 megawatt floating plant at Mukunpunipur water reservoir in West Bengal. So a discussion has been carried out in terms of energy generation, minimizing evaporation loss and amount of emission CO2 which could be emitted whenever conventional with compare conventional power plant. So it is found that a PV plant can generate 860 gigawatt hour energy, recover uh, 21,756 million liter of water, and reduce 7 lakh 52,000 ton of CO2 emission. So now I am just coming to the point because you already waiting for me. Now why I choosing Mukund Manipur, because it is a hot and arid region. So I'm going through the main topic. Hot and arid region. That's why, and there is a lots of water scarcity. So this reservoir was especially developed to conserve water for land, as water becomes scarce in this area during summer. This area could be improved as by installing a PV plant, because this area is already been used for tourism purpose. Thus, it can be further beautify with some photovoltaic panel, means a PV plant, and fountain show also could manage water. So of Mukutmanipur area of reservoir is 124.32 square kilometer, depth water level and maximum irrigation area is 700. So that's considering area it is only is a plant at Mugut Manipur. We can see that average temperature always remains at moderate condition every time, and in summer it is above than 40 degrees centigrade sometimes. So, and before choosing a site for first of the irrigation. So the proposed is so here is the floating plant here. So some of the suitable criteria for selecting a PV plant. So first of all, this area is already used for the tourism purpose, so it is connected to the near substation, Khatra substation, and national highway is close to the site, and place is seismic hazard free zone, and there is a no tall tree. If there is a tall tree, then bird can soil the it's not happening. So from literature, I already told that the 1 kilowatt PV system require maximum for PV installation. And also I found that 10 to 25% water body surface area is required for installation. So I am considering just minimum area. Thus present site could be used for installing 310 megawatt floating PV plant, considering this 10% area. So now energy generation calculation, if we consider, then energy generation depend upon the solar radiation module area and power. And CO2 emission is 22. We can calculate the amount of CO2 that could be which could be occur in the traditional power plant, that could be saved by using this PV plant. So here is a curve for monthly expected generation by the plant. We can see that after February to July, generation is maximum, then generation is average, and just winter month generation is low. Now economic viability, so from the data of World Bank in 2018, it is found that floating plants require $1 to $1.2 US per watt power installation. So here is a breakup value of different parts of the, or different component of the PV system. So now present case plant installation cost, considering this plant installation cost could be 2,542 crore, and it is found that energy that could be generated, it is 860 gigawatt hour per year, valuing 559 crore per year, and current average unit cost is 6.5 kilowatt hour is considered. That plant maintenance cost is 2%. Payback is found to 5 years.
Dr. Misra, you have
310 megawatt.
Excuse me, Dr. Misra, you have 2 minutes remaining. Okay. You have 2 minutes
finish
remaining.
your work. Finish the presentation.
Okay. So it could also save the cost of land if a similar power plant also built in Mejia, Bakura. So we could save some cost for land cost around 78.61 crore. So thus present study can delineate that would have enough potential to develop a PV plant. So, and around 860 gigawatt hour load demand can be served by this plant, and saving vacant land also. And if we consider the CO2 emission, then 752,000 ton per year CO2 can be reduced then compared to the conventional plant, and 2,70,056 million liter of 21,756 million liter of water also could be saved, as plant panel saved the water evaporation below it. So these are the references.
Okay, that's an informative presentation. I have just one question. Can your scheme be implemented in Sundarban? Because many water bodies are there, but in a small trench.
So it could be because many natural calamity is much more, I think,
Exactly.
then it could
It's
have
unstable.
unstable.
Yeah, that is the
Dr.
reason.
Singh?
Yeah, that may be the reason, one reason. Natural
That may
calamity.
be the reason. Yeah, natural calamity.
That's fine. Nothing from my side. Yeah. Nice.
Okay, I do not have any question.
Nice thing. Devajit Mishra Sahab, lots of network issue was there from your end. Actually, I think.
Finally,
sorry, sir.
Finally, it was okay. Yeah. All
Finally,
is
it was
good
okay
that
and
ends
done.
well.
So
Yeah, that's true. Yeah. Okay. So
Okay, sir.
it's a nice session. Once again,
Thank you, sir.
I'm taking my bye from everybody, and Dr. Singh, Dr. Abhijit Kundu.
Yeah.
thank you, sir. Thank you. So
Thank you very much.
the program is very,
Yeah.
everything is very,
Wish
very much
your conference will be a great success.
Program is very much successful, Dr. Arjit
Very
Kundu
much
Sahab.
successful.
Okay, sir. Thank you, sir.
Yeah.
Thank you.
Yeah. And nicely coordinated.
Okay, sir. Okay, sir. Thank you.
And lot of thanks.
Send me on my mail the tabulation sheet, the number, the gradation mark.
Okay.
Please send me to my mail. Thank you very much, sir.
By tomorrow morning, I will send, sir.
Okay, sir.
Okay.
Bye, sir. Bye. Thank you.
Bye. Thank you.
Okay, bye.
Bye.
Have a nice day. Bye.
Thank you, sir.